This video is an overview of CSection Plus. CSection Plus and CBeam constitute a package of two numerical tools devoted to the computations of homogeneous or composite sections and beams. Even though CSection Plus is part of a pack, it may be seen as an independent tool dedicated to the computation of the mechanical characteristics of any homogeneous or composite section. As to CBeam, it's a tool dedicated to the computation of homogeneous or composite beams under any loading and boundary conditions. However, CBeam is not independent. It requires that the mechanical characteristics of the section are first calculated by CSection Plus. This video, which presents CSection Plus, is followed by a second one about CBeam. CSection Plus, which comes with CBeam, is an improved version of CSection. CSection Plus provides the same mechanical characteristics computed by CSection, plus some additional characteristics that are useful for CBeam. It's imperative that the user of this video has previously seen the CSection video to learn about the characteristics computed by CSection. This video about CSection Plus is limited to the description of the additional characteristics provided by CSection Plus. What are the additional characteristics offered by CSection Plus? We have seen that CSection determines as sectional deformation modes the Poisson's effects and the out-of-plane warpings. These deformation modes are required by CBeam in order to compute the mechanical behavior of the beam. However, they are not sufficient to correctly describe the behavior of a thin-walled profile. Indeed, a thin-walled section can be easily deformed by distortion. The figure below shows an example of distortion for a thin section. Distortion may be interpreted as a bending of the section contour around itself. A distortion can also be seen as a change of the shape of the section profile. This slide presents the 3D deformed shape of two thin profiles computed by CBeam. One can know the distortion of the current section. In CBeam, an arbitrary distortion is approximated by the combination of n simple distortional modes. These n simple distortional modes are the additional sectional characteristics computed by CSection Plus. How are they computed by CSection Plus? The way used to identify a simple distortional mode is the following. We consider a Saint-Venant problem with a particular uniform lateral load, and we extract from the corresponding 3D solution the distortion of the section, which is due to the presence of the lateral load. It can be shown that such a simple distortional mode can be deduced from the resolution of a 2D problem defined only on the section. To obtain n simple distortional modes, one has to consider n cases of lateral loads. The choice and the number of loads are defined by the user directly on the section. For example, for this I section, the user can choose these 5 cases of load to obtain 5 simple distortional modes. CSection Plus computes systematically and by 2D FEM the distortional mode that corresponds to each one of the load cases. The 5 load cases defined for the I section can be summarized in the left figure. But the user could choose a larger number of cases, for example the 11 cases presented in the right figure. In fact, each case is chosen to cause the local bending of a branch or a part of the section contour or any part easy to deform. As illustration, this slide shows the 11 distortional modes related to the 11 load cases defined on the I section. To conclude, keep in mind that as CSection Plus is also an independent tool that can be used to help section design, shape and material. CSection Plus provides, as CSection, the mechanical characteristics of any homogeneous or composite section and additional distortional modes when a world section is involved. All these characteristics constitute a set of information on the section mechanics and the beam behavior that will result. In particular, all the sectional deformation modes will be used by CBeam to compute the beam. CSection Plus is developed on Matlab platform and can be used as a Matlab tool. On a common PC, the complete treatment of a section is usually about a few seconds. Lastly, the graphical interface of CSection Plus is designed for an immediate and easy use by an engineer or technician. And using CSection Plus doesn't require particular theoretical or numerical knowledge apart from the usual knowledge on sections and beams. This ends the overview of CSection Plus. The next video is about CBeam.